We'll go ahead and get starting right away with part 2 of the solutions video for the Newton's second law situational practice sheet. Here we have a basketball star exerting 3,225 newtons to the gym floor to accelerate his body upward. Determine the acceleration of the player. So here we're going to go ahead and draw our force diagram right away. He is exerting an upward force, so we will have an applied force, and we will have a force due to gravity. His force due to gravity is mass times the gravitational field strength. So he has a mass of 76.5 kilograms. We'll multiply that by 10 newtons per kilogram to get 765 newtons. And we know that he applies 3,225 newtons. Determine the acceleration. So to determine that acceleration, we want to use Newton's second law, where the sum of our forces in y equals the mass times the acceleration. Well, to find the sum of our forces in y, we can also write this as the up forces plus the down forces. In this case, our up force is 3,225 newtons, and then our down force would be negative 765 newtons, so that the sum of our forces in y will turn out to be 3,225 minus 765 for a total of 2,460 newtons. This number we will then plug into Newton's second law. So we have 2,460 newtons. We'll divide that by his mass is 76.5 kilograms to find our acceleration. So his acceleration for part A will then equal 2,460 newtons divided by 76.5 kilograms to get 32 meters per second for an acceleration. Now I want to determine the final speed of the player if he endures this force for 1.5 seconds. So here we are going to want to use one of our kinematic equations. Our final velocity equals acceleration times time plus our initial velocity. His initial velocity we can say is 0. We have an acceleration of 32 meters per second, and it gives us a time of 1.5 seconds. So we're given a time. His initial velocity is 0, so if we multiply 32 by 1.5, we'll get a final velocity of 48 meters per second. Number 6, we have a free fall ride where they experience an upward normal force to stop their falling bodies. So we want to know what the normal force is to accelerate 52.1 kilograms upward. Well, in order to do this, we first need to know what his force due to gravity is, so we can find our net force. So we have our force due to gravity will equal his mass, which is 52.1 kilograms, times 10 newtons per kilogram. So we will get that his force due to gravity is 521 newtons. And now we're going to want to know what normal force we need to cause an acceleration of 27.4 meters per second. So now we want the sum of our forces in the y direction, which will be the mass times the acceleration. So we know his mass is 52.1 kilograms, and we know their acceleration is 27.4 meters per second per second. So the sum of the forces in y will then work out to be 1,427 newtons. So if that is the sum of our forces, that means that our up force must be that much greater than the force due to gravity. So this number is also our up force plus our down force. And we know that our down force will be negative 521 newtons. So this up force, the normal force, will then be 1,427 plus 521 newtons, and this will equal our normal force. So after doing that calculation, we see that our normal force is 1,948 newtons. Number 7 gives us a hockey player accelerating a puck with a given mass from rest to a velocity after a certain amount of time. Determine the acceleration of the puck and the force applied by the hockey stick to the puck. First, we want to determine the acceleration of the hockey puck. So we know that it starts at rest. So we're going to use some of our kinematic equations here. So we're going to use that we know our final velocity is acceleration times time plus our initial velocity. The initial velocity is 0. The final velocity is 50 meters per second. So if we rewrite our equation to solve for acceleration, we'll get that our final velocity minus our initial velocity divided by time will yield the acceleration. So now we want to know that our acceleration, our final velocity of 50 meters per second minus our initial velocity of 0, and then we're going to divide that by our time, which is a very, very short amount of time, 0.0121 seconds. So by dividing 50 by 0.0121, we get an acceleration of 4,132 meters per second per second. So now I want to determine what the applied force was neglecting resistant forces. So if we're neglecting resistant forces, we're just looking for an applied force. So here our applied force will equal our mass times our acceleration. We're given a mass of 0.167 kilograms, and we just found our acceleration to be 4,132 meters per second per second. So by multiplying those two numbers together, we will see that a 690 Newton applied force impacted the hockey puck. Next problem, we have a skydiver is accelerating downward at 3.29 meters per second per second. We're given the mass of the skydiver, determine air resistance on the skydiver and his parachute. So first we're going to want to find his force due to gravity. And to find his force due to gravity, that again is just mass times gravity. So that would be his mass, which is 67.2 kilograms, times the gravitational field strength, which is 10. So his force due to gravity is 672 newtons. And he is accelerating downward. So if he's accelerating downward, that would be a negative acceleration. We're going to want to find the sum of his forces in the y direction. So that would be his mass, 67.2 kilograms, times his acceleration, which is negative 3.29. So the sum of his forces in y will then be 67.2 kilograms multiplied by negative 3.29 meters per second to get a sum of the forces of negative 221 newtons. Once we know that sum, we know that negative 221 newtons will equal the air resistance, that up force, plus the down force, and in this case our down force is a force due to gravity, and because it's going down it's negative, of negative 672 newtons. So by adding 672 newtons to both sides, we're able to isolate the air resistance to get an air resistance of 451 newtons. The same skydiver opens his parachute and slows at a rate of 7.2 meters per second. So now he has an upward acceleration. His force due to gravity is still 672 newtons. But now as we find the sum of his forces in y, his mass is the same, 67.2, but now his acceleration is 7.2 in a positive direction. So the sum of his forces in y will be his same mass, 667.2 kilograms, multiplied by 7.2 meters per second to get a positive upward force of 483, and we can actually round it to 484 newtons. That will be his upward force. That will be his net force. So now his net force, 484, will equal the air resistance, and we still have negative 672 newtons for his force due to gravity. Our up force is the air resistance, and remember we're adding the down force, which is negative 672 newtons, because that force due to gravity is pulling down. Our net force we just calculated to be 484 newtons. So now, by adding 672 newtons to both sides of the equation, we are able to find that now the air resistance exerts a force of 1,156 newtons.